Hello pre-calc. So here is a video of an application of our sinusoidal functions, and this one is a predator-prey, though not a logistic one. So we have some predator populations vary sinusoidally with time. A fox population in a national park was at a low of 200 foxes after 3 years of a research study. So here at 3 years, the low is at 200. After 6 years, that's from the initial start, so that would be here, it was at a high of 800, which is going to be up here, so we want to label all our axes. So that's at 6 years, we're at a high. So basically what that does is that gives me half of a cycle, because that gives me a low and a high. Didn't quite make it there. So let's start to label our axes and fill out this graph. So 800 plus 200 is 1,000, half of 1,000, 3, 4 is at 500. So that's going to be our new sinusoidal axis. And then if I go another 3, so that would take me to 9, I will be at another low. So you came around and then we have another low, and basically it's going to continue. So at 12 we would be at another high, and let's just kind of graph it out a few places. So at 15 you're going to be at another low, dot, 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 dot. All right, so what do we know? We know that our vertical shift, which gives you your sinusoidal, is at 500. We know the amplitude is going to be this distance, so that's going to be 300. We know our period is 6 years, but I also like to figure out at this point, so we're going to do this in radians, so that's 2 pi over 6, so pi over 3 is what our b value is going to be. And then our phase shift, the horizontal shift means we're going to start, well, you know, oh my gosh, we have options here. That means, that was kind of silly that I was actually at a high. If I go back 3, every half cycle is 3. So what we could do to make this easy is make our phase shift 0. That kind of makes things easier. All right, and then let's see, what do they want us to do? Find the equation. Oh, silly me, it's all down here. So amplitude, let's fill this in, 300, period was 6 years, vertical displacement was 500, phase displacement, I'm going to do 0, and then we can write our equation. So that's going to be 500, it's a positive cosine because it starts high, 300 cosine, and then we can just say pi over 3 times t. There we go. All right, so that gives us our equation to work with. It's always nice if you can get a phase displacement of 0, because that simplifies the solving process. Predict the fox population after 7, 9, and 12 years. So we have a couple things we can do. At 7, we are going to want to actually plug in 7 and calculate that on our calculator, your calculadora. So if I go P of 7 and plug it in, I believe I'm going to get 650. So just make sure that you are capable of plugging it into your calculator and getting that. So that'd be foxes. At 9, we actually have that on the graph, so we know that that's going to be 200 foxes. And at 12, we actually have that on the graph as well, so that's going to be a high of 800 foxes. So that was nice. So we only really have to plug in one value. All right, now it says foxes are considered endangered and hunting restrictions are in place if the population drops below 300. So here is 300. I'm going to kind of draw a line. Do, 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 do. So that line represents 300. Sorry, it's not the straightest of lines. At what point in the study will hunting restrictions first be lifted So what they're asking about, so first be lifted is when the foxes first come out of being under 300. So this is the point that we are really looking for. All right, so we are going to set up an equation where 300 equals our equation, 500 plus 300 cosine pi over 3t. Okay, so we have to go through and solve this. So we subtract 500 and then divide by 300. I'm going to kind of do these all in one step, simplify that, and then we're going to take the inverse cosine. So that is now going to equal pi over 3t. And so what we want to do is go to our calculadora and get in radian mode, so make sure you're in radian mode, and if I go second cosine negative 2/3, I get a lovely, again, don't forget your 3 decimal places, so this would be plus or minus 2.301 plus every 2 pi n equals pi over 3t. And then what I'm going to do is I am going to multiply both sides by the reciprocal here, so this will be 3 over pi, gets multiplied to everything, and we'll continue over here. So I still have 2.30, I have the whole decimal on my calculator, which is nice, so I multiply by 3, divide by my pi key. That is going to give me plus or minus 2.197 plus, so here my pi's will cancel, 6n. Notice you always should get back the same period that you started with. That is going to equal t. All right, so our goal is to find what is that first time when it is lifted. So if I kind of look at different, well, let's say I was going to find a lot of different equations. So I like to put in here negative 2.197 and positive 2.197, kind of make a little table. And then we're going to keep adding 6. So if I do 6 minus 2.197, I get 3.803. And I do believe, it's a little close, that is the value we're looking at, because 2, if I subtract, that's going to be negative. This next one is going to be 8.197. So this is going to be our value. And that basically says we can, so after, say, 3.8 years. Doesn't make sense to do more decimals than that. All right. And again, if you're wondering how I got these, remember n is 6, so here I let n equal 1, which is like adding 6 to what previously came.